So as you can see, the structure of a compound L is shown, and R is represented the hydrocarbon chain. So this part we have a hydrocarbon, like carbon and hydrogen is there. And we don't know how many hydrogens are there and how many carbons are there. The student was asked to deduce the full structure of L. So first part, the student analyze L. Student analyze L in the infrared spectroscopy. The following spectrum was obtained. So this is a spectrum. Remember the range from 1700 to 1800, this range is for carbonyl group. So means this X is representing a carbonyl group always, because this range is always refers to a carbonyl from 1700 to 1800. This range from 1600 to 1700 is refers to a carbon double bond, and the Z, it's around 1000 to 1100. This always refers to a presence of a carbon single bonded with oxygen. So these are the range for the infrared spectrums. So we know in the compound L, there is C double bonded with O. So this is X is actually because of this one. And in compound L, there is also CO bond, like carbon bonded with oxygen. So this is due to Z. So what does it mean? There's a carbon-carbon double bond, because when there's an absorption from 1600 to 1700, that's a carbon-carbon double bond. So it means this hydrocarbon part, which contain carbon and hydrogen, there must be a carbon-carbon double bond. So the first part of the question is, the absorption of a Y shows that the absorption Y shows that L has a carbon-carbon double bond is present, and in the R group, and there, like this R group, there's a carbon-carbon double bond. And student decided to use hot concentrated. If you use hot concentrated, remember two things, like if we have a compound which is having a carbon-carbon double bond. So if there's a compound with a carbon-carbon double bond, and we add cold potassium KMnO4, potassium manganate 7. So what will happen? It will turn into a diol. Like example, the double bond will break, it turn into a single bond, and the OH will be attached to both of the carbon. It will turn into a diol. But when it is hot, concentrated KMnO4, so what is the effect of adding a hot concentrated KMnO4? The carbon-carbon double bond will break, like C double bond, and oxygen will be attached. So the two carbons which are having a double bond, that will break and the oxygen will attach. Both reactions are refers to oxidation, because addition of the oxygen is there in both of them. But if it is a cold, it will turn into a diol, and if it's a hot, the carbon-carbon double bond will break. As a result, the oxygen will be attached. And then if it is turned into an aldehyde, because if the compound is an aldehyde further oxidized to carboxylic acid. If it is a ketone, there's no oxidation happen. So ketone remain as it is, but aldehyde will turn into a carboxylic acid. So they mention here that the student decided to treat L with a hot concentrated. So if he treated with a hot concentrated potassium manganate, it means the carbon-carbon double bond will break and it will have CO both sides. So name M. So first part we have to name M. This is compound M. So the compound M contain how many carbon atoms are there? You can, if we draw the structure, this is CH3, then there is CH2, then there is CH2, then CH2, then CH2, and then COH. So if a compound contains 4 carbon atoms, 1, 2, 5, 6 carbon atoms, so it will be hex because of 6 carbon atoms. They will have a single bond, so N, and because of this group, functional group, so it will be oic acid. So this M is actually hexanoic acid. Then use the information in D to deduce the molecular formula of L. So how we can deduce the molecular formula of L? First, we have to identify like how L is formed. So in this group, because this C double bonded with O is there, and that is turned into a carboxylic acid like this till here. So we'll have this compound C double bonded with O. Then O is there. Then this part. So 1, 2, and 3. Like as you can see, this is 1, this one is 2, and this one is 3. And there will be a double bond here because this part. So in this compound, we have to deduce the formula for the molecular formula for L. As you can see, the L is producing two carboxylic group. So this part of the chain, there is a carbon-carbon double bond, because when there's a carbon-carbon double bond, that will, in the presence of the hot concentrated KMnO4, it will being oxidized. So when we simplify this, the structure, so we have C double bonded with O. This O is there. Then this is 1, 2, 3. So till 3 here. And this one, we have like how many? 1 and 6 carbon atoms are there. So C double bonded with C. 1, 2, 3, 4, 5, 6. This is the original structure of this L. How we identify this is the original structure of the L? Because when we use a hot concentrated KMnO4, the carbon-carbon double bond will break. And when this carbon-carbon double bond will break, this will have, like this carbon-carbon double bond will break. So this will have C double bonded with O. And this will also have C double bonded with O. But because this is an aldehyde and we still have an acidified KMnO4, so this aldehyde will further oxidize to carboxylic acid. So this will turn into a carboxylic acid. This will also turn into a carboxylic acid. That's how the two products are formed by the oxidation of this compound L. So we have to deduce the molecular formula of L. So what is the molecular formula of the L? Because in L, C double bonded with O and OH is being added. So C double bonded with O and OH is added. So we count the carbon atoms. So this is 1. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many carbon atoms are there? There are 12 carbon atoms. How many hydrogen are there? So when we count the number of hydrogen, this does not have any hydrogen. This will have 2, 4, 5, 6, 7. This will have 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this will give 20 hydrogen. So C12, H20. And how many oxygen are there? This is 1 and this is another. So how many oxygen? 2 oxygen are there. So this should be the molecular formula of compound L. As a compound L is formed by the oxidation, the compound L being oxidized by hot concentrated KMnO4. So means the side chain, the R group contain a carbon-carbon double bond. Is it clear, this one? M cannot be oxidized. M is a compound which cannot be oxidized. Why M cannot be oxidized? Because M is already a carboxylic acid. So in short, whenever you have a carbon-carbon double bond is there, So when you have a carbon-carbon double bond, let's say it is written CH3, it is there H, and this is CH3, and this is also CH3. And you use hot concentrated KMnO4. If it is a hot concentrated, usually for Edexcel student, hot concentrated is not part of the syllabus for them. For Cambridge, hot and cold both are part. Like if it was a cold, it will form a diol. But if it is a hot concentrated, what will happen? This will break down into CH3. H is there, C double bonded with O. First, the oxygen will be attached. That is the first thing. First, oxygen will be attached and it will turn into aldehyde and a ketone. Then aldehyde further oxidized to carboxylic acid. So this will become C double bonded with O and OH. This is what happened. First it is aldehyde, then aldehyde further oxidized to a carboxylic acid. So in this compound, as you can see, the two products which are formed, both are carboxylic acid. So it means the so when we want to link the chain here, so means the double bond is here, this part, because the part which is being oxidized, that is where the double bond exists. So if you remove this double bond from, if we remove the C double bonded with O, and we remove this as well, so there will be a carbon-carbon double bond at this point. Then this carbon is there with one hydrogen, and then there are total remaining 5 are there. So if I draw a skeletal formula, 1, 2, 3, 4, 5. This is the original structure of the compound. Is it clear? If this is the same question for Edexcel, then simply what you have to do, it will just turn into a diol. Next is excess of a zinc powder is added to 50 grams of 0.5. What is sir, if we had to name the oxidized L product here instead of M, what is, which one oxidized L? This one, you mean? Then this is an ester. This is a combination of ester and carboxylic acid. How it will turn into a diol? Because when we use a cold solution, when we use a cold KMnO4, the double bond will break and it turn into a single bond, and the OH will be attached here and the OH will be attached here. That's how it will turn into a diol. So this is 1, 2, 3, 4, 5. And this is a cyclic compound is there. How L will turn into a diol. So first I will draw the structure of the L. And I just have to change the, like place the double bond, break the double bond and place OH. So 1, 2, 3, 4, 5, and 6. So how it will turn into a diol? So this double bond will break down. And this will have OH and this will also have OH. That is how it will turn into a diol. But if it is a hot concentrated, it will break from the position where the two carbon-carbon double bonds are there and both are attached with oxygen. And if it is an aldehyde, it can oxidize to a carboxylic acid. If it's a ketone, no further oxidation happen or occur. So here the enthalpy change of a reaction, this is the calculated value and the data booklet is a standard value. We need the percentage error. So if we need the percentage error or the percentage difference, the formula to calculate the percentage difference is maximum minus minimum divided by, if I know the standard value, divide by standard into 100. So I just need the numbers here, no need for the signs. So maximum value is 217. The magnitude minus the minimum is 185 divided by standard value, which is 217. because a data booklet is a standard value into 100. So that will give us the percentage difference in our results. Is it clear? So the percentage difference is always the maximum minus minimum divided by the standard value into 100. If you know this, if we don't know the standard value and we want the comparison between the two experimental values, in that case, the formula for the percentage difference will be the maximum minus the minimum divided by the mean into 100. If we don't know the standard value, then we divide by the mean. But if we know the standard value, then we'll divide by the standard one. The commercial disinfectants often more viscous by adding propane 1,2,3-triol to aqueous solution. How it will make a disinfectant more viscous? So you can see prop in 1,2,3-triol contain OH, 3 OH groups. And what is the tendency of these OH? These OH groups can form a hydrogen bond with the aqueous means water. So they can form a hydrogen bond, more hydrogen bonds per molecule will be formed with the water. That's why it will become more thick or viscous. Like they will have more attraction between the particle. As a result, the particle have greater attraction. That is what makes it viscous or thick. Is it clear, this one? So it is about the intermolecular force. Another thing, very common misconception about the bond angle. Look, first thing you have to memorize that bond angle and the bond length. I mean the bond angle and the shapes. But let's say if we have a molecule which is C triple bonded with C and H is there and H is there. And they ask us predict the geometry of this molecule and state the bond angle. So first thing, how many it's not about you count the total number of bond pairs for the whole molecule. You only take one of the atom, any one of the atom which is surrounded by other. So any one, because hydrogen I cannot take, hydrogen is not surrounded, it's only one side it is bonded. Let's say I took this carbon. When I will take this carbon, how many bond pairs are there? It has 4 bond pairs overall. And there is a zero lone pair. There is no lone pair. But when I'm predicting the geometry, like I will say there are 3 bond pairs and there is 0 lone pair. But when I'm predicting a geometry, the double bond, triple bond, single bond, they are classified as 1. So this is classified as 1 and this is classified as 2. So in terms of the geometry, because the double bond and the triple bond are in the same line, so as a result, what will happen? It won't make difference to the geometry. So when I'm predicting the geometry, so in exam, even you don't say like it has 2 bond pair, but you will say there are 4 bond pairs and 0 lone pair. And out of 4 bond pair, there are 3 of them. Like there's 1 triple bond and 1 single bond. So with reference to 1 triple bond and 1 single bond, it's look like it has 2 bond pair. And with 2 bond pair, what should be the geometry with the 2 bond pair? It will be a linear structure. And what is the bond angle for the linear structure? The bond angle is 180 degrees. So it will be 180 degrees. But when we talk about like carbon-carbon, double bond is there and there's a hydrogen. So now when we count the bond pair, again, there are 4 bond pairs and there is no lone pair. But when we predict the geometry, there is a double bond. 1 double bond is there. And there are 2 single bonds. So how many total are there? 1, 2, and 3. So whenever we have there is no lone pair and 3 bond pair. So what will be the structure? It will be trigonal with a bond angle. What is the bond angle of the trigonal? It is 120 degrees. So this will be 120. So whenever you're predicting a geometry, you don't have to count the whole molecule bond pairs. Take only one of the central atom and check what is around, how many bond pair, how many lone pair. So even there's a double bond, there are total 4 bond pair and no lone pair, but double bond is categorized as 1 and the single bonds are two of them. Is it clear, this idea? And when we draw the, like showing the electron, the overlapping of the orbital, like sigma in the pi bond, like if we have O2, oxygen is there, or for C, we have Cl2. Cl2 means chlorine single bonded with chlorine. When we write the configuration of a chlorine, a single chlorine atom, it is 1s2, 2s2, 2p6, 3s2, 3p5, because chlorine belongs to group 7 and there are 17 electrons. So for chlorine, in the p orbital, it has 3px is there, 3py is there, and 3pz. So 3p first, there are 5 electrons. So first they will occupy singly, then there's a pairing up. So one of the electron is available in the pz orbital. So when we draw this chlorine, this is one chlorine and this is another chlorine. So if we draw pz, like you can draw in any direction. Let's say this is representing pz for one and this is representing pz for other. So the orbital are completely overlapping. So whenever there is a single bond, it will always be a sigma bond. Single bonds are always sigma. But if we have a double bond is there, like oxygen, in oxygen, oxygen double bonded with another oxygen. Now, when we write the configuration for oxygen, oxygen is 1s2, 2s2, 2p, 4 is there, like because 8 and 16 is there. So 2p, 1s2, 2s2, 2p, because we want to make total 8, so 2p4 is there. The p is having, so 2px, 2py, and 2pz. So when we show the pairing, so 1, 2, 3, and this. So there are two p orbitals are available. So this is one oxygen. Yeah, 2p4. I was writing 2p4. Just so now for each oxygen, 2py and 2pz are available. So when we draw 2py, so this, let's say this is 2py and this is 2py. So 2py overlap, so there will be a sigma bond. But now because x, y, and z are always 90 degree or perpendicular to each other. So if this is y, this is z, this is x. So x is not needed. Now y, so this is y and this is another y. So the orbital will overlap. It will not be able to overlap or partial overlapping is there. What this result? This result in a formation of a pi bond. So whenever there is a double bond, one will be sigma, another one will be pi. When there is a triple bond, then one will be sigma and two of them will be pi. Like this is for oxygen double bonded with another oxygen. And for nitrogen, if we have N2, so nitrogen triple bonded with another nitrogen, the configuration 1s2, 2s2, 2p3. So when we check the 2p orbital, 2p x, y, and z, so it will occupy singly. So when we show nitrogen with nitrogen, so we draw, this is 2py, like let's say this is 2py and this is also 2py. So they will completely overlap. There will be a sigma bond. Then we have, or 2px, you can also say, then if this is 2py and this is also 2py, so they cannot partially overlapping. Axis is parallel, so this will be a pi bond. And then we have a 2pz and 2pz. So there will be also partial overlapping. So there will be a pi bond again. So it will be pi, sigma, and pi. So whenever triple bonds are there, one is sigma, two of them are pi. When there's a double bond, one is pi, one is sigma, and when there's a single bond, it's always sigma. Then can you explain the test to determine the if it's an aldehyde or a carboxylic acid? Okay. Look, Aldehyde can be oxidized. First thing, if you want to test the carboxylic acid, if we have C double bonded with O and we have CHO. So how I can distinguish it's a carboxylic acid, not an aldehyde. So I will add either a hydrogen carbonate or a carbonate. So if I add a hydrogen carbonate or carbonate, because acid can react with a carbonate, which will give fizz, bubbles, or effervescence. But the hydrogen aldehyde cannot react with it. That's how we can distinguish. If I want to show the presence of the OH group, even this OH group may belongs to an alcohol or it may belongs to a carboxylic acid. So if I want to show a presence of OH group, so what we add PCl5. So PaCl5, it will give a misty fumes that gives an evidence that there's a OH, and this OH can be for alcohol, can be for carboxylic acid, any of them. And if I want to distinguish between aldehyde and a ketone, like if I have a ketone and I have an aldehyde and I want to distinguish, so we can do a silver mirror test, or Fehling or Benedict solution can be added. If I do a silver mirror test or adding a Fehling or Benedict solution, aldehyde give you a positive result. It will form a layer of a silver, or a Fehling or Benedict solution turn from blue to red PPT will form. But ketone cannot be oxidized, so it does not give any positive result. Is it clear how you can distinguish? What is a magnesium ribbon test? Magnesium ribbon test can also be used to check the presence of acid, because whenever we have a metal plus acid gives salt and hydrogen. So if it gives the bubbles fizzing, it means acid is there. So magnesium ribbon can also be used to identify that a compound is acid. Or if you add a sodium metal, there are also other tests like, yes, like main test is like test for aldehyde, ketone distinguishing, or test for presence of OH, bromine water test is there. You have to memorize all of them. These are the there was a question in the past paper for mechanism of reaction 3. Can you explain? Reaction 3 is formation of it's a nucleophilic substitution. SN reaction is there. Yes, I will show a mechanism how the reaction 3 can proceed. You have to show the same way. Like, let's say we have a halogenalkane. It can be primary, secondary, or tertiary. If it is a primary, it will undergo SN2. If it's a tertiary, it will undergo SN1. But it's the same way you have to show. Like if it is we are reacting with a mixture of KCN and HCN, and we want to show a substitution reaction. So what is this CN? This CN is the nucleophile. Like carbon is there, it is having hydrogen, 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 and there's a Cl. This will be partial negative, and this will be partial positive. So we have a CN with a negative charge and a lone pair. So CN will attack on the carbon positive, and if it's a primary halogenalkane, the bond breaking and bond forming will take place at the same time. So Cl will try to break the bond and the CN will try to form a bond. And what will the charge on this? It will have a negative charge because of the presence of the CN. And once the Cl break the bond, then this compound, it's the same way substitution like the way OH is substituted with a compound. So this will be H is there, H is there, H and CN. And the chlorine is being removed. That is the mechanism of this reaction. This is SN2. Why SN2? because the reaction depends on the presence of the nucleophile as well as the presence of halogen alkane. But if it was a tertiary halogen alkane, then first we have to break the bond and then the bond will form. So if it is a tertiary halogen alkane like CH3 is there, CH3 and Cl. So the presence of the nucleophile will not affect the compound because it's due to the steric hindrance as the methyl groups are there. So first the chlorine will break the bond. Once it will break the bond, so it will form a carbon cation. And this carbon cation will be stable because it is surrounded by alkyl groups. And this carbon cation, now the attacking nucleophile is there that will attack on the carbon positive. So this is SN1 reaction and then the product will form. Is it clear, this one? So this is the same way. These are even all of them are SN reactions. Now this is a mechanism for reaction 4, how the reaction 4 proceed. The idea of a mechanism, like example, this is again SN reaction. It can be SN2 or SN1. If the bond breaking and bond forming take place at the same time, it will be SN2. If the bond will break, then the new bond will form, it will be SN1. So how the reaction proceed here? We have this attacking nucleophile, the ammonia with the lone pair that will attack on the carbon positive and chlorine will try to break the bond. So they did not show us the intermediate here, like whether a bond breaking and bond forming take place at the same time. So what will happen? Like this carbon will be there, which is having chlorine. Hydrogen is there, and there's a methyl group. And we have ammonia, NH3, a lone pair is there that attack on the partial positive. So this is a nucleophile. Then the bond breaking and bond forming is taking place at the same time. This is NH3. So what will happen? The chlorine will take both of the electrons. When the chlorine take both of the electron of the carbon and the electron of the chlorine, then this nitrogen will donate one of its electron to carbon. So when the nitrogen donate one of its electron to a carbon, and nitrogen now will form 4 bond. Why nitrogen is forming 4 bond? Because nitrogen atom is having a structure like this. It can form 3 bonds. But when nitrogen loses one of the electron, it will have a positive charge and now it can form 4 bonds. So nitrogen loses one of the electron to a carbon and then it is able to form 4 bonds. So this is nitrogen, hydrogen, 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 then one with carbon. This hydrogen is there, and CH3. And this nitrogen is having a positive charge because it has formed 4 bond. But the nitrogen, like any ion, is not that stable. So to gain the stability, nitrogen take one of its electron back from a hydrogen, so it loses one of the hydrogen. When it take its electron back, the charge on the nitrogen is being removed. So this charge is being removed. And the hydrogen, which is lost, combined with ammonia, so it will form ammonium ion. This is what happened. So first is a nucleophile attack, NH3 attack. It will get a positive charge because the nitrogen is forming 4 bonds. And then the hydrogen, which is additional, like it loses one of the hydrogen to gain the stability. And that hydrogen combined with ammonia to produce ammonium ion, NH4 ion. Is it clear? It depends on one thing, like whether we have an excess of ammonia, because this reaction, the same mechanism is shown accordingly that what will happen. But one thing, that we may have an excess of ammonia or we may have an excess of a halogen alkane. Let's say we have an excess of ammonia, a halogen alkane is there, and it is reacting with excess of ammonia. Ammonia is more than enough. So what will happen? And out of NH3, NH2 will be attached here. So it will be CH3, NH2. And one of the hydrogen combined with one of the hydrogen combined with chlorine produce HCl. This HCl is acidic and we have an excess of ammonia. So another, like this HCl which is produced reacted with another ammonia molecule as we have an excess, so it will produce ammonium chloride. So the product of this reaction will be methyl chloride plus ammonium chloride. Sorry, methylamine plus ammonium chloride. That will be the product of the reaction, like methylamine and ammonium chloride when we use excess of ammonia. But if we use a limited amount of ammonia, if we have like CH3Cl and ammonia is a limiting factor, limited amount, so ammonia is not too much. So this reaction will continue until all of the hydrogen of the ammonia are replaced by the carbon chains. So first what will happen, it will form CH3NH2 plus HCl. Then this CH3NH2 will react with another methyl like halogenoalkane. So this will form CH3 in a bracket 2 NH plus HCl, like another hydrogen replaced. Then this compound like CH3 in a bracket 2 NH combined with another methyl group CH3Cl halogenoalkane. So it will form CH3 in a bracket 3N plus HCl. So these are the two different results depending on whether we are using excess of ammonia or we are using limited amount of ammonia. If excess of ammonia, the reaction only lasts, like with the halogenoalkane, one time it react and the reaction then remaining will react with HCl to produce ammonium chloride. But it's a limited amount, then every time the hydrogen will be replaced by the carbon chain and reaction will continue until all of the hydrogen are replaced by the carbon chains. Yeah, if limited amount of ammonia, then more substitution happen with hydrogen, like more hydrogen will be substituted. Yeah, still it is a nucleophilic substitution reaction, that's right. But the number of the substitution will be more. Like multiple times it will undergo substitution. But with the excess of ammonia, only single time it will undergo a substitution. Is it clear? Any other question or a doubt related to any topic? You have sent me a question. Okay. So less than a minute left. Join from another link and I will answer remaining of the question which you have sent.